Good morning to everyone. I'm Manjulatha from Data Science. In this video, we are going to learn about Rolle's theorem. Here is the statement of Rolle's theorem. Observe the statement in detail. F is a function defined over a closed interval a comma b into R, satisfying the three properties, that is, f of x is continuous on closed interval a comma b, f of x is differentiable on open interval a comma b, and f of a is equals to f of b. Then there must be a real number satisfying the condition f dash of c is equals to 0. Let us prove this theorem. Since by first property f of x is continuous on closed interval a comma b, we know that every continuous function is bounded. So now f of x becomes bounded, and every bounded has infimum and supremum values. If capital M and small m are supremum and infimum values of f of x and a comma b, that is, supremum of f of x is equals to capital M and infimum of f of x equals to small m. Case 1, capital M equals to small m, that means supremum equals to infimum. Here f of x is constant function, means the derivative of constant function is 0. F dash of x equals to 0. In particular point of c, f dash of c becomes 0. Case 2, capital M is not equals to small m, that means supremum is not equals to infimum. Here I have two possibilities, that is supremum greater than infimum, that means capital M greater than small m, and supremum less than infimum, that means capital M less than small m. Coming to first point, that is supremum greater than infimum, there exists a point C belongs to a comma b, f of x equal to capital M. Replace x by c, f of c is equals to capital M. This is the supremum value. Then f of c plus h less than or equals to f of c, and f of c minus h less than or equals to f of c. This can be rewritten as f of c plus h minus f of c less than or equals to 0, f of c minus h minus f of c less than or equals to 0. By the definition of f dash of x formula, apply limit and divide it by h. Then limit h tends to 0, f of c plus h minus f of c by h less than or equals to 0. Then f dash of c is less than or equals to 0. This is equation number 1. Limit h tends to 0 minus f of c minus h minus f of c by minus h greater than or equals to 0. Then f dash of c becomes greater than or equals to 0. This is equation number 2. From equation 1 and 2, we can conclude that f dash of c is equals to 0. Coming to next point, that is supremum less than infimum, there exists a point C belongs to a comma b, f of x equals to small m, put x equals to c, f of c is equals to m. This is the infimum value. Then f of c plus h greater than or equals to f of c, and f of c minus h greater than or equals to f of c. Then this can be rewritten as f of c plus h minus f of c greater than or equals to 0, and f of c minus h minus f of c greater than or equals to 0. By the definition of f dash of x formula, apply limit and divide it by h. Then limit h tends to 0, f of c plus h minus f of c by h greater than or equals to 0. Then f dash of c becomes greater than or equals to 0. This is equation number 3. And limit h tends to 0, f of c minus h minus f of c by small minus h less than or equals to 0. F dash of c becomes less than or equals to 0. And from 3 and 4, f dash of c becomes 0. Here is the problem of Rolle's theorem, that is f of x equals to x square minus 2x into e power x and 0 comma 2. Given f of x equals to x square minus 2x into e power x. By Rolle's theorem, we have f of x is continuous on closed interval 0 comma 2, and f of x is differentiable on open interval 0 comma 2, and f of a is equals to f of b. Then there exists a point x belongs to a comma b, then f dash of c becomes 0. F of x equals to x square minus 2x into e power x. F of 0 is equals to 0 square minus 2 into 0 into e power 0. It becomes 0. Then the value of f of 0 is 0, and f of 2 is equals to 4 minus 4 into e square, that is 0 into e square equals to 0. Then the value of f of 2 is 0. Then we can say that f of x is continuous at 0 comma 2. F of x is equals to x square minus 2x into e power x, f dash of x is equals to x square minus 2x into e power x plus e power x into 2x minus 2. Then f dash of c is equals to 0 plus 1 into minus 2 is equals to minus 2. F dash of 2 is equals to 0 plus e square into 2 equals to 2e square. Then f of x is differentiable at 0 comma 2. We have the third property, that is f of a is equals to f of b. We have the f of a value is 0 and f of b value is 2, that equals to f of 0 equals to f of c, and we got the values of f of 0 and f of 0, f of 2, that is 0 and 0. That means it employs 0 equals to 0. Therefore, f of a is equals to f of b. We have f dash of x equals to 0. That means x square minus 2x into e power x plus e power x into 2x minus 2 is equals to 0. Here I have taken e power x as common, and x square minus 2x plus 2x minus 2 is equals to 0. In this bracket, 2 minus 2x and plus 2x get cancelled, and e power x goes to that side, and 0 by e power x equals to 0. That means x square minus 2 equals to 0 remains. Therefore, x square equals to x equals to plus or minus 2. At point x equals to plus or minus 2, the theorem holds. Here is the applications of Rolle's theorem. When a ball is thrown vertically upwards, its initial displacement value will be 0. That means f of a is equals to 0. And when you reback the ball, then displacement will be 0. That means f of b is equals to 0. Here, f of a is equals to f of b. Then the Rolle's theorem is satisfied here. And coming to COVID situation, when the wave started, cases have been increased. And when the wave is getting low, cases have been decreased. Here the Rolle's theorem applies. And when we go with sunset, the upper limb of sun disappears below the horizon. Then the condition shows here Rolle's theorem is applied. Thank you.